Hi, my name is David Blissett. In this clip I'm going to be giving you a quick walkthrough some of the WebGL work that I was involved with over the past year or so. Okay, so at the moment what you're looking at is a project where we managed to get a Land Rover, Range Rover in the browser using the tools from PlayCanvas. Now, to keep this clip short and relevant, I'm just going to skip back over to the actual project, the dashboard that is, and just load up the actual project itself. So going to the actual editor. Shouldn't take a second to load. This is one of the really good things about these tools. Unlike going through something like Maya and Unreal, you've got the capability to be able to upload your assets to the server, being this the PlayCanvas server, and be able to load up your scripts, load up your textures and your models, and combine everything within the actual browser itself. So if I drill into this location here, I can see that I have a Land Rover model. I can see that I've got a material that I've actually set up, so you can see the actual material itself. And then the various textures to give the variation for the car configuration. I'll make a bit more space here. Load this up so it can actually get at the scripts themselves. So what's going to be relevant here? Something like rotation. So if I want to be able to handle mouse gestures, you can come in, wire up the various events, the parameters to help do the calculations, and then you're handling things like mouse move, mouse up, touch start, touch move, touch end. So again, you're in the JavaScript universe, but you're also doing 3D. So you haven't got to worry about the complexity of getting things loaded on the canvas and making sure that you wire up everything correctly as far as the latest 3D specifications concerned. You can do a lot of the work in a way that's similar to what you'd be doing as if you were coding a website, for example. Okay, so to actually start the project, once you've actually got it set up and you've got all your scripts and all your models loaded the way you want them, then it's just as simple as pressing the play button. And again, as long as you've optimized your models correctly, it shouldn't take that long for the assets to load into the browser, and boom, there you go. Really quick, quite responsive. The whole purpose of what we've got here is that you should be able to change the color, change the shaders. Depending on the readout that you'll get on this webcast, you should be able to see that we're getting a reasonably nice sheen. Now again, this is a very low spec model. I think in total we're using maybe roughly about 50,000 polygons for the whole asset. I mean, more time could have gone into work on things like the metal rough for the tires themselves. I mean, it's a bit shiny, but what we were doing at the time was purely R&D. How do you get vehicles in the browser so an end user can actually manipulate them, work with them, so on. Okay, so we're roughly 3 minutes in. We want to make the best use of your time, so what we're going to do now is skip over to another project but this one was actually done by PlayCanvas themselves. Either that or they did it for BMW. So let's see if we can find the actual project itself. So here you have a series of games that they've actually created, and they're freely available, full source codes available. You can go into the website and launch them and play with them. It's got over 1,200,000 views, but they don't make the source code available. The quality of work that went into it, that you're going to be breaking some kind of copyright if you're going to be able to take their code and replicate it for another supplier. So that's probably why they didn't want to let that source code go. But here you go, you got the i8 come back in the browser. It looks quite clean. Now if you've got a well-trained eye, you can tell areas where it's got a bit of faceting to show you that it is something really quite low poly, but how can I say, efficient enough that so it can actually be loaded in the browser. So we can augment this now, and here we are going into the vehicle. Again, you can tell it's low poly, but you get the gist of the experience. What you should be able to do is be able to preview the vehicle as though it was a real vehicle. I'm pretty sure BMW do not use a 3D configurator on their website, but you get the general idea just going in. All right, so with that being said, what I was able to do was kind of go into the background for the code and grab the actual assets themselves, grab the scripts, and then start reverse engineering to somehow come up with the equivalent of what they've got here. Now, what they have was an earlier version of the PlayCanvas APIs themselves. So even though I had the scripts, just trying to play it wasn't good enough. You actually had to do the upgrade to the latest version in order to get any kind of feedback. So what I'm doing here now is I'm actually loading my version of the i8 project, BMW i8, and yeah, I'm going to give you a high level of what we've got here in terms of what we've been able to figure out based on what they've got. So we're going into the scripting section for the actual platform, and this is how I've actually been able to load the assets, and I'm going to show you that in a second. But first, let's quickly have a quick scan of what we've got here. So these are the various assets that I had to download and then re-upload to my own project, and then go through the actual APIs themselves and try and figure out how it is that you actually load these assets on the fly. Because it's very much smoke and mirror. I don't have the full SFBX, but I've been able to short circuit it sufficiently so that I can actually play with their assets in my project. So rather than just talking at you, let's see if we can fire up and show you the equivalent of what we've been able to reverse engineer. Now it's not 100%, but it's sufficient thus that I can actually get their assets into a PlayCanvas session and actually preview the equivalent of what they had in their project. So that is the BMW i8. I mean, I probably spent maybe about 3 weeks just doing the reverse engineering exercise to be able to come up with this, but in terms of being able to get into PlayCanvas in the first place, get your head around what it is that we're actually doing and how to work with the APIs, I'd probably say I was up and running within about 2 weeks. The idea was that I needed to have a low resolution model that I can work with in the first place. So within Unreal Engine, I was working with a high fidelity version of this asset, which was roughly about 1 million polygons. And I was able to do the retopology work to get that down to 50,000 polygons. I might be overstating that. I mean, the tires, I know that the tires themselves did take up quite a lot of geometry, but yeah, it was still pretty good to be able to get it down to under 100,000 polygons and still be able to get it to reflect the level of fidelity that I was just able to demonstrate in the browser. Now we're going to take a quick jump over to some work that we did in Unreal. Sorry, got the gun firing off. Okay, so essentially we started off with this principle of wanting to be able to get the vehicles. So we had many models, all high fidelity models, and we know that we're not going to play with those over the web. But the general idea was, let's see if we can actually get a very good high fidelity readout within Unreal. We hit that mark, and then once we hit that mark, the bosses come up and say, well, what we're really targeting is 1 gigabyte asset down over mobile. So I kind of gave the company a walkthrough of the general principles of what we need to do in terms of optimizing the model, essentially making it a game res model. And they bought into the principle, but this is what we were able to get in Unreal. So I've just pressed F5, we're doing a refresh That's 140 megabytes to be loaded. The asset itself was probably about 20 megabytes on disk, but literally you're talking about the engine need to come down, the WebAssembly bindings, getting it self-compiled, and then loaded up. So for me, looking on the kind of scope, I probably had maybe about a month to do that, and recognizing that, hey, it's 140 meg. This is not efficient if you wanted to be able to demonstrate capabilities of generating sales of vehicles in the browser. So the next pullback was how do we recover? How do we recover essentially? So that's how PlayCanvas came about. So did some quick R&D, and within two weeks we're able to get the actual assets actually running within the browser. And notice we're still waiting for this to compile, and there you go. So that took maybe about a minute to be able to load the actual assets, get everything compiled, and then give us the readout. Now again, we could have spent more time trying to get a more realistic view, but if you can look on it, the physically based shading is really good, considering that we're in the browser. It's almost as though you're on the PlayStation. But that's that asset. We'll show you life cycle between both PlayCanvas and Unreal Engine. And now I'm going to swing over to Unity, where for the client that I'm currently working with now, they're doing some work with the human anatomy. I can't go into detail on it, non-disclosure agreements and all that, but that's my own asset. So based on the requirement that they had and what we're trying to work on, went away and did some R&D, all with the knowledge of what happened with Unreal, going forward with Unreal in the browser. Don't get me wrong, Unreal is a brilliant engine generating games, Fortnite, so, $6 billion game, but for the browser you probably want something that's more a bit more robust, and the offering from Unity is pretty good. It still has its own drawbacks, but in terms of the load time, here we go. I just pressed F5. Give this a couple seconds, maybe a bit more than a few seconds. Boom. So that was like 20 seconds to load an asset. We've got the logo pop up, and eventually, there we go, we've got the skeleton come back. So right, I've had you now for about 14 minutes. That's the capabilities that we have as far as WebGL are concerned. All the assets that you've seen, I would have done retopology work on them or built up the assets themselves. Things like texture work, I'd probably go into something like Substance Designer or Substance Painter. A lot of this work goes back maybe about a year ago, maybe about 8 months. And then obviously we did some work, you might have seen on the documentation for Baby Stars 123. That's our own brand. Done the YouTube channel with 3D rendering going on via Unreal, and then generating the movies and putting them up in the browser. Right. If you've got any comments, feel free to pass them through the relevant channels. Again, my name is David Blissett. Thank you for your time, and I look forward to talking to you soon.